Okay, now we are going to derive the relation between J bar and electric field E bar. Okay, for this let us consider conductor. Say it is having the length L. L is the length of the conductor. Okay, A is area of cross section. A is the area of cross section. Area of cross section. A is the area of cross section, and V is the potential difference between the two ends of the conductor, and Vd is the drift velocity. Vd is the drift velocity. Vd is the drift velocity of free electrons. Then the uniform electric field. The uniform electric field. The uniform electric field. The uniform electric field in conductor is given by E is equal to V divided by L. E is equal to V divided by L, or V is equal to E into L. Take this as equation number 1. Okay. By Ohm's law, we know that V is equal to IR. V is equal to IR. Since R is equal to rho into L divided by A, this equation becomes V is equal to I into rho L divided by A. I into rho L divided by A. Take this as equation number 2. Okay. From equations 1 and 2. From equations 1 and 2. Okay. From equations 1 and 2, we can write EL is equal to I into rho L divided by A. Here L and L gets cancelled. Remaining is E is equal to I into rho divided by A. Or we can write this one as I divided by A. I divided by A is equal to E into 1 divided by rho. Okay. But we know that I divided by A is nothing but J. Okay, is equal to J. Therefore, J is equal to E divided by rho. J is equal to E divided by rho. But 1 by rho is nothing but sigma. Then this equation can be written as J is equal to sigma into E, or J bar is equal to sigma into E bar. Okay, so this is the expression which shows the relation between J and E bar. This will be asked for 5 marks. You have to compulsorily draw the diagram for this expression. Let us consider L is the length of this conductor, A is the area of cross section, V is the potential difference, and Vd is the drift velocity. The uniform electric field is given by E is equal to V by L, or V is equal to E into L. Take this as equation number 1. By Ohm's law, V is equal to IR. From that, take the value of R as resistivity into L by A. When you substitute it in Ohm's law, it gives equation number 2. From equation number 1 and 2, when you compare these two equations, you will get EL is equal to I into rho L divided by A. L and L gets cancelled. Remaining is E is equal to I into rho by A, or I by A is equal to E by rho. Okay, we know that I by A is equal to J. When you substitute the value of I by A is equal to J, it becomes J is equal to E divided by rho. But 1 by rho is nothing but the sigma. Okay, sigma is equal to 1 by rho. Therefore, J is equal to sigma E, or J bar is equal to sigma E bar. This is nothing but the vector form of Ohm's law. J bar is equal to sigma into E bar. This is the vector form of Ohm's law, where J is nothing but the current density, sigma is the electrical conductivity, and E is the electric field. Okay, so you have studied about the Ohm's law and what are the limitations of the Ohm's law, and on what factors does the Ohm's law depend. There are 2 types of devices. One is ohmic device, another one is non-ohmic device. Ohmic devices means which obey the Ohm's law. Say for example, the galvanometer or the ohm meter, we can say. These devices which obey the Ohm's law are called as ohmic devices, and the devices which do not obey Ohm's law, those are called as non-ohmic devices. For example, the transistors or the discharge tubes or the semiconductors, those are called as non-ohmic devices.